Thank you. Great introduction by Bill. Really excited to share with you on Chiplet Innovation Ecosystem on behalf of myself, Amber Huffman from Google, and Peter could not make the trip, but was integral in developing the material. So let's dive in. So first off, what is a chiplet? I'm just going to start off in some of the basics, right? So historically, we've had a die as a package as a chip. And die of transistors and wires, package has your pins, your cooling plate, your mechanical. But recently we have a lot of multiple die in a package where we look at TPUs, GPUs, I mean TPUs are close to my heart at Google, with more than 30 dies per package. You've got Sapphire Rapids that we have a picture of on the screen where they're going past the reticle limit, so they split it into 4 pieces to be able to continue to offer increasing levels of performance. And then of course AMD's Rome approach, which was a heterogeneous approach versus a homogeneous approach that Intel took. So in the rest of this talk, each die is a chiplet. So what's the promise of chiplets? Let's talk about why some people go after chiplets, because there's different reasons, right? So chiplets enable construction of devices that exceed the maximum reticle size, like we just saw with Sapphire Rapids, where they're going to something very, very large and that can't fit in the reticle. Another one that a lot of us are excited about, Google's certainly excited about this concept, is reuse of chiplets, reducing time and cost. So for example, one of the areas that some of us are very excited about is I/O. There's not a reason for us to redo I/O again and again and again, and it can be in an older process node. Another is breaking a monolithic design into smaller pieces to improve yield. All of us know as you develop a new process node at the earlier part of the curve, you may have trouble yielding larger die. And so if we can break into smaller die, that allows us to get to the faster node or the leading edge node much more quickly. Another one is obviously chiplets manufactured using different processes. You can reduce cost, and you can have different levels of integration. And you can, of course, another key thing there is logic may take advantage of the leading edge node. I can leave my analog on the older node. Obviously, analog and I/O debug is often our long tail, and so maybe I can leave that in the older node for longer. Then, of course, how can we use different chips from different teams and different companies? I mean, it would be nice if, as a community, we can develop these modular building blocks together and really evolve into a chiplet marketplace where we can all build really interesting products and not have to do everything ourselves. And I think the AMD EPYC Rome shows a few of these principles of the center I/O chiplet being in an older node, and then you have 8 core chiplets in a more leading edge node, and they can stamp down 4 of them, 8 of them, more of them, which makes for pretty interesting times. So what is our challenge ahead of us? We're really in an ecosystem evolution opportunity of going from a monolithic CPU to this clean sheet of paper where we can just throw down on different interposer technologies or using EMIB or other technologies, this advanced packaging of creating this new canvas that all of us can realize, which is exciting. But it's an ecosystem, and my experience in ecosystems is when we start, it often takes, from the time we get a complete standard and other things and develop all the pieces, it can be a 5 or 10-year journey. And in chiplets, I think we are steadily in the, stage 3. So if we start out, we're proprietary, people are doing chiplets on their own. Great examples with AMD and with TPUs, GPUs, other things. We have examples today, but it was proprietary. Then we get to standard physical interfaces, and we are seeing that with a bunch of wires, with OpenHBI, with UCIe. Then we get to layering on standard protocols, then moving on to standard form factors and really getting to plug and play. And so we have a little bit of time for us to get to the true plug and play, but let's talk about that journey. So in the proprietary phase, we've already touched on the Sapphire Rapids and the EPYC Rome examples, but large companies doing their own chiplets because they can, but how do we really evolve from the proprietary into the broader based adoption and standard and less boutique? It's been pretty exciting. I mean, when you actually take a look at it, we have 5 different standard physical interface standards, and we probably have more than what's showing here, right? Between AIB, USR, XSR, OpenHBI, which a lot of great work done within ODSA at OCP with that. Bunch of wires, more great work done in ODSA. at OCP there, and then the emergence of UCIe that came about earlier this year. So we really have that critical mass of the great ideas throughout these of how we can coalesce around the die-to-die physical interfaces that are really going to carry us forward. So then the next stage is how do we overlay standard protocols? So if you take a look at the UCIe standard, they've already overlaid PCI Express and CXL. Now, as we think about it, there's also the challenge of, is that enough? I mean, if I look at, do I want an AXI or a CHI mapping? What are the mappings that I need in order to be able to build interesting building blocks? Because PCIe and CXL may be a little too heavyweight protocols for certain applications. So how do we evolve and get the standard protocols on top of those physical interfaces that will really carry us forward? The next is standard form factors. So one of the things that you'll see that all of us are working on is how do we look at standard form factors? When we're talking at chiplets, one of the challenges is we really have to start understanding if we want to have a chiplet marketplace where we're sharing I/O chiplets, well, we need to, it's physical, so it needs to fit. And so how do we start to understand different standard form factors, thermal, bump maps, and whatnot, so that we can actually have interoperable designs? And then getting into plug and play. So you've heard about a lot of what we are doing here, manageability. If we think about how do I know what is present? How do I configure a chiplet? Am I going over I3C and am I using MTCP or MCTP? I always confuse those. How are we going to go in and configure, and what is the protocols and what are the knobs in order to configure? And then security plays a huge piece. So the security discussions are ongoing right now. As you guys saw at OCP this year, we've had a huge discussion about Calyptra, for example, on integrated roots of trust. When I look at a chiplet, do I have a root of trust on every chiplet, or do I have a quote-unquote primary chiplet that handles the root of trust, and how do I do that? So we're in those discussions right now. So now that we have the physical interfaces, now how do we build on the security manageability so we can actually have common plug and play and really move forward on this journey? So the call to action is specifications are emerging. I think we're really getting to where we're starting to gel around where we head, but there's so much opportunity on security, manageability, form factors, and interoperability. How do I really understand that when I plug these two things together and debug at an SoC level, how do I make that happen and make that happen efficiently? So there's so many great specs out there. I encourage you to download any of those listed, and let's really move forward to making the SoC the new motherboard. We're really moving on to where what PCI has done for I/O standards. Let's see what we can do in chiplets. So thank you very much.